This episode was made possible thanks to Gotopia.tech.
Hello everyone, my name is Rebecca Parsons and we're here to discuss software technologies that stand the test of time. And we have 8 panelists who are each going to make a proposal for a software technology, and then the other panelists will weigh in on what they think of that idea. So Nicki, let's start with you.
All right, thanks very much, Rebecca. So my humble submission is SQL, the structured query language used to access and maintain relational databases since the dawn of time. I think the roots go all the way back to 1974 when Chamberlain and Boyce actually published their sort of famous paper. And it's really the language that we have today is based on what that was sort of 45 years ago. So for me, the sort of 3 acceptance criteria that I had was, what was the original purpose? Does it still fulfill that? Has it actually evolved gracefully over time? And how prevalent is its usage today? So I think on the first point, when relational databases originally were created by Ted Codd, the query language back then was based on maths, but Boyd and them really wanted to do it in a way where it could be more accessible to users that were not trained in mathematics and computer programming. And today you have engineers, data scientists, your basic sort of Joe Soap, who can generally write SQL to get data out and into the database. And even my dad, who's a bank manager, can actually write SQL as well. So I think it ticks that box, hopefully. But it's used across the board, not just to query the language, but also not just to query the database, but also to maintain it. I think in terms of the evolution, the language structure has really, and the base syntax has remained the same, although it has had many sort of evolutions. So SQL, I think it was 86, with the very first ANSI standard, had the support for the select, insert, update, and delete statements, exactly the same ones that we have today. SQL 92 then introduced things like outer join, set operations, and even in 2003 there was the introduction of XML querying through XQuery and stuff, which you can argue whether that's a good thing or not. But the language evolved as more things kind of came along. And I think whilst I concede that SQL itself doesn't have one sort of standard to rule them all, the dialects are all kind of different, I think the core has really remained true. And in terms of its prevalence, I think you really can't escape SQL. It's used for every single relational database that's out there. It's de facto query standard. So prevalent maybe that a whole class of other databases are named as being not SQL. And so I would say that in my conclusion, I just say select star from table is as well known today as it was back in 86.
Yep. Rebuttals. Or support.
I don't have a rebuttal, but I do support that. That's a beautiful technology to mention, so kudos for that. In fact, I would say probably it goes beyond SQL itself. For example, Microsoft's efforts towards Link was inspired to take that idea into data in memory, not just database itself. Though, however, I spent my youth with object-oriented databases, so I kind of escaped that SQL, for a number of years until I was thrown back into it, but I can definitely appreciate that.
My possible rebuttal would come from the perspective of DBAs, though, which is that SQL is a tremendously powerful declarative language that allows you to ask almost impossible questions against data structures that they were never designed to answer. So it produces a huge abuse of perfectly good relational databases. But it is a very powerful language.
Yeah, that's fair enough. That's fair enough. Yeah, I mean, I was actually torn as to whether to go for a relational database itself or whether to go for SQL, but I ended up going for SQL. So
good choice.
So I might jump in and just say that so I come from statistics and data science and more from the education side. I'm a professor at Carnegie. Even when I was doing my kind of undergraduate degrees and even maybe the first master's degree, SQL was very much like, yeah, you probably should learn 10, 20 years, watching how important it's become in kind of our education training programs. So all of our students who are graduating with sort of statistics, machine learning, data science degrees are all getting exposure to SQL. So even as you say, like, that it's been around for a long time, it's interesting to watch kind of the educational programs are now really focusing on it as well as other, relational databases and languages and stuff. So we are, from the education side of things, we are embracing it as well.
Okay. Well, let's move on then to Eberhard.
Yeah, so my proposal would be NeXTSTEP. NeXTSTEP is an operating system that Next built, the company that Steve Jobs did after he was fired from Apple in 1985. It's a Unix-based operating system. It pioneered technologies such as display PostScript for the graphical user interface, object-oriented development with Interface Builder and Project Builder. And some pretty interesting applications were built on NeXTSTEP, such as the game Doom, and also obviously the first web browser and the first web server created on Next at CERN in Geneva. The operating system originally worked on Next hardware. Just 50,000 machines were built, and at one point they quit production, so it seemed like a failure. And I think that's the interesting point about technologies that stand the test of time, that they evolve and adapt. So it was then ported to other platforms, HP, Sun, and Intel. The API was ported over to Windows with OpenStep for Windows. So sort of write once, run everywhere, and it lost that battle to Java. So again, it had to shift. And Next was bought by Apple in 1996. And nowadays, Xcode, the development environment on macOS, is based on Interface Builder and Project Builder. The doc that we have on macOS is originally from NeXTSTEP. Display PDF is, well, an updated version of Display PostScript. And the Cocoa NS classes, NS is basically NeXTSTEP. And nowadays it runs on iOS and watchOS. So those are pretty much updated versions of NeXTSTEP. So it actually runs on hundreds of millions of devices. So I think it's interesting how such a sort of niche technology that was pretty much ahead of its time gained, well, into the center of so many devices nowadays, and had such a long history being ported from the original Next hardware over to PowerPC, Intel, ARM processors, mobile platforms these days. And nowadays it's probably part of our everyday life, even though it seemed like a failure at first sight.
Excellent. Responses?
If it's possible to make somebody nostalgic by talking about technology, you get the badge of merit for that. I'm almost in tears right now. I spent my graduate student life playing with Nix computers late in the night, so I could not agree more. I had a dislike, honestly, for Mac computers back in time. While all my friends would be using it, I was kind of wondering why. Until I really started using it is when I discovered, oh my gosh, this is actually Next being re-implemented on the Mac. So, I mean, I could not agree more than more in this particular topic.
Yeah, and there is a Next manual right behind me if you look there closely.
Is that what we're trying to point to?
I think your point about evolution being an important aspect of this technology's standing the test of time is an important one. I must admit, I was quite surprised when you said Next. It's like, wait a minute.
Yeah, and I found also the contrast interesting concerning SQL, because that's a technology that has been around for quite a long time and it never really changed. While this is something where market changed and the whole idea, it changed from being more like an object-oriented API developer focused. It was a hardware story before that, and now it is something that, as I said, is the foundation of lots of mobile devices nowadays.
All right. Well, let's move on then. Venkat, you're up.
Oh, all right. So I was going to talk about a technology, but I wanted to really broaden that to something a little bit more and then tie that back into a technology. And I'm going to say it's our desire to really simplify the complex world around us. And if you look at everything we do as programmers and various other things, we just get into so many complexities. When I look at programmers, people trying to solve problems, what beats us down every single day is complexity. So the question I want to really ask is, what can we do to mitigate the complexity? And any kind of technology solutions that can help us can greatly help us in getting through our lives, managing all the things we have to build. And in that regard, I see functional programming as the one that has really stood the time for managing complexity. I don't look at functional programming as a tool with monads as people, threaten everybody else. But I really look at functional programming as a way to really remove accidental complexity. Well, in general, when we are working with things, we have to deal with two kinds of complexities, as we all know. Those that are inherent complexity, which come from the application and the problem and the domain, and the accidental complexity that often comes from the solution space. And while a lot of programmers, I would say probably most of the programmers, are very familiar with imperative style of programming, how ironic that something that's so familiar is yet so complex. And we are that frog in that pan being fried and boiled every day. And we have endured this pain not because it's simple, it's because it's familiar. On the other hand, what is not so familiar to us is actually quite simple, because in functional programming, the code begins to read like the problem statement, and as a result, it becomes a lot more expressive. And in a way, I would say this also, comes back to other activities in human life. If you go back to 1900 and ask what were the automobiles that were most prominent in the world, those were the electric cars that were prominent back in 1900, which was forgotten, a generation or maybe 2 or 3 generations of people who were around were driving gasoline cars, and we are getting excited about electric cars again. In a similar way, it's kind of funny to watch that a generation of programmers have gone through imperative style of programming, not even ever getting a taste of functional programming, and all of a sudden, just like electric cars, we are excited about functional programming. So my vote is first to reduce accidental complexity, and by way of doing so is to vote for functional programming.
So I'm going to have a question rather than a rebuttal. Do you think that, or are you saying that functional programming necessarily creates clearer, easier to read programs than imperative languages? Or is it perhaps more to do with familiarity and the ability to, you can write terrible code that's really impenetrable in any language? Do you think it's really the case that functional programming is inherently clearer and less or?
Yeah, that's definitely a good question. And I'm going to say, because of familiarity, imperative style is easier to write, but harder to read in the long run. And because of unfamiliarity, functional is harder to write, but easier to read once we get marginally familiar with it. So fundamentally, I do believe that for any given complex problem, imperative style is harder to read, functional style is hopefully well written, is easier to read.
Although I will say the scariest program I ever saw was a Lisp program, but it was written by somebody who had programmed his entire life in Fortran. And so he wrote a Fortran program in Lisp syntax.
I had, to your point, I had somebody email me a piece of code and said, I know you're a big fan of functional programming, so here you go, I wrote one, this is horrible. And the person who wrote it said it's horrible, and I replied back saying, I totally agree, but here's a refactored code if you want to take a look at it.
It's an interesting point though as well, because I think if you look, for example, at something like Scala, which can do both sort of OO and functional, it's quite interesting to see when an original sort of Java program or OO programmer gets hold of Scala. It takes quite a long time before the functional style sometimes comes out, and you can actually get your head around that. So I think that point is very valid as well.
I think I've got one slight rebuttal. I keep coming across people who tell me they love functional programming, and I see lots of practical functional programming languages, and it's not like we can't learn new stuff. The JavaScript guys learn something new every 3 months, as far as I can see, and yet people are still not actually putting their money where their mouth is and actually betting on functional languages. So, I don't know, I think there's something missing. Maybe you need to write another book, Venkat.
And just a slight remark, I'm sometimes wondering what the world would be like if in the 80s home computers would have shipped with functional programming languages like Logo instead of BASIC. So then maybe the world would be very different.
I think there was one of the really early kind of home PCs. I want to something maybe called Orac that had something like Logo or Lisp as its. My memory is
I think it
failing me.
was false.
Symbolics workstations were native Lisp machines. They processed the Lisp VM in their hardware. So it has been done.
But they were quite expensive. I mean, the thing is that the kids grew up with imperative programming, so it seems intuitive to us nowadays. While if they had grown up with function programming, it would be function programming that seems to be intuitive for them nowadays.
Any final remarks, Venkat?
Well, I think, kind of going back to the discussion on, should we introduce imperative or functional to begin with, one of the things I do, I moonlight and teach part-time at the university, and I introduced a programming languages course mainly with the intention that I want the students to graduate knowing there is no one way to solve a particular problem. So I'm not going to say that functional is the right way to do things, but it's important for us to get a taste of different styles of programming. And then these are vehicles, and we have to choose what's right based on situation. But overall, I think that, and again, one of the other things I will quickly mention is I don't understand why people would pit object-oriented programming, something as opposed to functional programming. I don't see them as competing with each other in a lot of places. So I think the real enemy to programming is complexity, and functional programming tries to really attack complexity, and that's what I really want to focus on in terms of what we can do with this particular technology, which surprisingly has been around for such a long time. Some of the initial languages created were functional in nature, and I hope in the next few years we'll come around to embrace that a lot more than we do today.
Okay, thank you. Liz, you're up next.
All right. So I tried to think of something that I have used recently that I used very early on in my kind of programming career. And I think it's maybe going to be a bit controversial because I don't think it's actually that great, but it's a hammer that a lot of people continue to use. And it is the humble Makefile. I remember, running make commands when I was, a student, when I was first getting into kind of C programming. Only recently I've been going back to Makefiles because I've been doing some work on eBPF. Not only am I compiling C, maybe I'm compiling some Go code as well. Maybe I have, targets in different languages. There are other tools that you can use to build things, but it really struck me. I'm using this tool that I first used 30 something years ago. I still kind of don't like it in a lot of ways, but it does the job. So the Makefile.
I've wasted far too many hours putting tabs in the wrong place to ever love Make.
But do you still use it? Do you still use it though?
Not when I can avoid it, but maybe that's what Liz was saying as well. Sometimes there's a Makefile, so you have to just get on with it.
I mean, whoever thought that like different white space characters should have like different meanings? I remember having real arguments with PHP in the early days because a blank line at the end of a file would make a difference. So I am not a fan of meaningful white space, but I do think Makefiles are they do the job.
I was going to say, I wish they had learned from it and not go that way to Python. That's one thing that tripped me off. So, nothing makes me more mad than significant white spaces. But Make is such a love-hate relationship. I mean, I could not agree more with you. Had you said that you love Make, would have had a different conversation right now, I think. But I think we're in violent agreement here. I remember spending my youth with Make, and it's like, who in the right mind would do this stuff? But yet you had to, because almost everything you did used Make. Not that things that came after made it any better, and you kind of have to wonder, is a significant white space better than angle brackets with ANT? And that was a disaster for a few years. And I would say the only difference between Make and ANT is the creator of ANT publicly apologized to people for creating such an XML syntax. But I agree that, decades later, we are still looking for a better way to express our dependencies and build. So maybe another 40 years later, we can have this panel again and look back at how we're doing with the build utilities and how the world has progressed.
And there are so many other tools, build tools that came and are not used anymore, while Make is still there. So I think that's a very good point. It's not about how it's elegant; it's about how it's persistent and still there.
Yeah, it's kind of the definition of standing the test of time, really, isn't it?
Exactly.
That applies to roaches as well, but
The cockroach builders.
So, any closing remarks, Liz, before we go on?
I will just say, just reiterate, I'm not necessarily a fan. I just think they have longevity.
Understood. Rebecca.
Oh, sure. Thanks. So when I started thinking about this, I thought very much about the statistics and data science world because that's where I am. And so the first thing that came to my mind are the community built or the community developed tools that have evolved and grown and people are still using after decades. And they're using them in ways that maybe the original developers didn't even kind of imagine, but the principles were general enough that they could be extended. And so, for example, the R language is a really good example of that. So I think SS was created in 76 by John Chambers, I believe, at Bell Labs. And then S Plus came out in a commercial version around 88. But then R came along in 93 and sort of grew and became this monster of an ecosystem that's now currently supported by the R Foundation for Statistical Computing. But I mean, and there's so many other languages we use in statistics and data science as well, but it keeps coming back to this community-driven kind of organic growth idea that, I mean, I have middle school students and high school students who, when they're coming to learn about our school, tell us about the R functions they're building and the packages that they're making. And so somehow it's accessible enough that people can start very young, they can feel confident, they can contribute. There's lots of different ways to interface with it, command line, graphical interface, IDEs, right, through notebooks and such. So for me, I guess that's one example of a software technology, I would say, from statistics and data science would be that kind of R programming language. But I'm really referring to kind of the community and the ecosystem that it's kind of grown and built over the years. So that would be a good example, I think, for statistics and data science. But happy to hear what you guys think. If you use those, if you use that one, or if you prefer other tools.
No, so I think it's my responsibility to jump in on this and offer the rebuttal. And my first rebuttal would be, if that's the case, then why is R considered to be only be used in the realms of academia and not in industry?
Right, that's a great question. Yeah. And I think it's not the only thing that people are using in academia and statistics and data science. Thank you for asking that question. I mean, we're certainly teaching Python, we're teaching SQL, we're teaching all kinds of things. I think what people still use R for is a lot of and again, I'm coming from my field. They're still using it for a lot of data analysis, like visualizing things. And so then using R maybe in conjunction with other languages and other tools to do more of the more complicated statistical computing and things that we need now for today's kind of large data science problems. So it's more that R is like a common entry point, I think, for a lot of people who are new, and then they move off kind of into other things or in combinations. So, but I guess to your point, I guess I more meant what I like about it is, or maybe this isn't that R is standing the test of time, but kind of the idea of building an ecosystem that people can contribute to, like an open source community that can grow. I guess I mean that aspect of a software technology standing the test of time. I think that's really powerful.
I'm going to jump in and sort of agree and disagree. So my experience of R is very limited and somewhat dated. And my recollection of it is that because you get so many community contributed versions of different packages, I guess, you might have half a dozen different implementations of a very different function, but they'd all have like the parameters in different orders. And it would be really hard to kind of like, oh, I needed a different version of this function, but now I've got to move everything around. And that felt to me as if it were something that is kind of, it's grown organically, it's been community contributed, and it didn't feel like a very sort of self-organized community, where I think particularly, now the way that open source has become core to so much infrastructure. I'm really thinking about Kubernetes and other cloud native projects, where they're incredibly well organized, community driven projects that don't that still have that kind of very rigorous control and I guess careful consideration of how APIs might change. So I guess I'm disagreeing in the sense of I'm not a massive lover of R, but I am agreeing that communities can build and that we're seeing the evolution of really well organized community projects.
Yeah, and I would say that the development of RStudio and the Tidyverse framework in particular has moved more in the direction of what you're talking about. So there is a lot of kind of R, kind of going rogue, right? And people putting up packages and saying like, use my package and let's upvote that, etc. But there are also a lot of very principled frameworks kind of that are coming out now that frameworks that if you ask professors who were teaching in R 10, 15 years ago, they would be like, I've never even used that. So it's so, it's so new and it's so popular now. So I think a lot of like my current college students view R very differently from how I viewed R or learned it. I learned it far more what you're kind of describing, that you're trying to find the package you want. You're doing a lot of web searching, right? You're trying to do things. And the students who are learning it now are having a very kind of different experience. Although they are, another kind of community thing you could bring up is they also just believe that you can get everything just on like Stack Overflow, right? Or just like discussion boards. Like they just are, this is maybe taking the panel in a different direction, but like I actually worry sometimes about how people are learning how to debug and solve their problems, because some people are thinking like, well, here's a really principled way to go through this. Thank you. And then other people are like, I'm just going to Google this and see if somebody else figured it out. And then I'm just going to cut and paste their solution. And there's pros and cons there, but that's kind of another feature of the community stuff. And just with my last 30 seconds, I just want to throw out to the room that I think something that hopefully will stand the test of time, but it's a little bit newer in our space, is things like standard lib, or like libraries for JavaScript and Node.js that are allowing us to do numerical and scientific computing for some of these large statistical data science models on the web. So starting to build interfaces where we can run, and I'll throw out for Phil here, reinforcement learning or deep learning or regression models or all kinds of things. But we're doing it with these like standard libraries that are being built with JavaScript and Node.js. We see that a lot more now. And I'm hoping that becomes a software technology that stands the test of time, maybe in a few decades, et cetera. Thanks.
Thank you, Rebecca. On to you, Phil.
Thank you very much. That's good lead in there. I like the link. So I'm basically going to mix Rebecca and Venkat together, I think, and produce my answer. So when I was thinking of this, I was thinking technology, and I think like the generic definition of technology is scientific knowledge applied or something like that. And then I thought, well, what's the test of time? What does that mean? So I took it to mean something that's lasted as long as possible. And related to my work in RL and machine learning and stuff like that, I kind of gravitated towards just purely machine learning. And I know it's not technically a technology; it's more of a technique, I guess. But I think it's a really good case for this, because it's been around for such a long time, and I think it's going to be around for such a long time in the future. So I mean, generally using this idea of being able to learn rules, to learn models, to learn from data, as opposed to presupposing what software should do, and us being as software engineers assuming that we know what the right program should be. We should be learning from the world and learning from data and developing programs and software and models that are able to take advantage of that learning. So I was going to talk a bit about RL, reinforcement learning, which is the idea of learning from experience and trying things out and trial and error and things like that. And that's what my book's on, obviously. But I thought it's a bit too new. That kind of started around the 90s. So I stepped back a bit and went back to machine learning, because it really has been around since, the 1950s, 1940s, 50s is when it really started to blow up. And in fact, it's been around for such a long time that it peaked in about the 60s and then sort of tailed off in the 70s and 80s again. So, died off again and didn't re-emerge until the 90s. So I think that is standing the test of time, where it can go in and out of fashion. And I think somebody mentioned this earlier, this idea of cycles. Machine learning has already been through several cycles already, and I can envisage it going through several cycles in the future as well.
Cycle is a much nicer term than AI winter, which is the one I normally hear.
Exactly, yeah.
I also really agree, and that resonates with me about the cycles. We often hear things described as machine learning that I think some of us in statistics are like, that sounds like logistic regression, which has been around forever, but somehow it seems like it's new. But I think that kind of makes the point that you're making, though, is that these ideas have been around for a long time, how to learn from data, learn from the world around you. And I do certainly think that concept is, of course, standing the test of time. And I think it'll only get stronger and grow larger as we go. Yeah.
Yeah, exactly. And still the fact that logistic regression or logistic regression used for classification, which is always the most confusing thing to try and say and explain to people. It's been around since 1880s or something. So it's well over 100 years old now, and still commonly used in many models today. So that's definitely standing the test of time.
Anybody else?
I think we've got total agreement.
One thought there about sort of machine learning in general, more how it's used as a marketing term, which I'm sure is not really what you're referring to, but you do see a lot of companies using the phrase machine learning when I think what they really mean is storing some data in a database, remembering some variables. It's not quite the same as actually deriving any kind of real learning from a set of data. So I hope that form of marketing speak around machine learning does not last.
Yeah.
I agree with you there. A lot of times machine learning is used as really sort of simple data analysis, right? And thinking about extracting insights from data, but it's not really how we might think of as learning, right? Like or example, how Phil just described it. That's not, what's happening. But I think you're right. The phrase is ubiquitous. It's applied to all kinds of scenarios. So we'll see if that changes over time.
Yeah, it's such a philosophical problem, though. That's half the battle. It's like, how do you define learning? It's a philosophical definition. And that's why I specifically didn't use the word artificial intelligence or AI, because I think that's even worse for that. I think that's overused even more by companies, and I particularly don't like that term. But pros and cons.
Okay. Well, let's move on. Hanna, you're up next.
Thank you, Rebecca. So I feel like what I will propose is exactly the opposite that people would expect me to propose. And I'm really thankful for Venkat that you mentioned that complexity is the enemy of programming, or of the things we actually want to do. So I will propose the monolith, or the monolithic architecture, or the monolithic deployment, because I wish it will turn out to stand the test of time. Because I feel like we have abandoned this idea in favor of many other ideas, and we still haven't figured out solutions for main problems of these new ideas. So if we think about distributed applications, so from my perspective, there are far more problems that still exist than that we have solved yet. So personally, I've been working on application infrastructure for the last years, which is why I was working on the topic of service mesh, which was really interesting to me because the idea is to make teams more productive, right? With many things that are invented now, it's meant to make teams more productive. But thinking about it, I believe that there are more basic things we can decide that will make teams more productive. For example, the monolith. And so basically what I want to say is, if we would invest the same amount of time in improving or reinventing ideas just like the monolith that are technically simple, then we would come up with much better solutions than we have right now for distributed systems.
So maybe just one thing from me. So I think that in terms of one thing that I think I will agree with, something that we see in our sort of consultancy, is sometimes people will reach for a far more complex system before they go for something more simple, and they'll go for microservices because it's the flavor of the day and that's just what you do when you build a system nowadays. And I think that thinking is certainly not helpful, because sometimes that is just the wrong architecture for the problem at hand. And sometimes things are simple, and I think you should start simpler with something like maybe a monolith type. But then I think over time, I think there are cases where the architecture and the requirements would dictate that you might need to go to something more distributed just because the requirements dictate that. But I think I would agree with you that sometimes people start at the wrong end now. They start at the sexy microservice end when they should start at the more simplistic end. But my rebuttal would be that I think certainly distributed systems done right does still have a place, or does really still have a place.
Mm-hmm. Yeah, I feel like, I feel like we might not have tried to make monoliths done right. This is what I feel, but I agree that of course there's no one solution for everyone and everything, but I think it's worth thinking about complexity very, very early on, and choosing the right thing for the situation. Yeah.
So I feel like I have to come in with a rebuttal, because I have, books about containers and posters about Docker on the wall behind me. And, I'm a big fan of cloud native. I completely agree that, you need the right architecture for the job, and microservices is not always it. Functions as a service is not always it. Sometimes, maybe the monolith is the straightforward approach. But I think we see so many advantages in things like the ability to scale things independently, the ability to distribute components across, multiple servers, the ability to secure individual components and sort of add extra layers of security around those individual components. That although there is a big cultural change to moving from a monolith to moving to the kind of cloud native microservices approach, there is a ton of benefit if you're building a complex distributed system. I don't think it's just hype. I think people are doing it because it's turning out to be successful and allowing people to ship functionality quickly. So I don't think it's just a flash in the pan. Whether in 30 years' time we will come back and say, microservices stood the test of time. Well, we'll find out.
I think distributed systems have stood the test of time, though, in one way. It might be complicated, but I think the underlying principles and the way that they work are still the same, and that hasn't changed. But how we apply them and whether we apply them correctly, I think is where we run into trouble.
I think the idea that Hanna proposes is a very controversial idea, definitely because, she's saying what a lot of us don't want to hear. That's one of the complexities of the world we live in. I often associate a lot of what we do to resume-driven development. We want to do it because everybody else is doing it, and how could I not be building another microservice? And I always question this. If overnight 10 million people wake up and say, I got to build microservices, how could that possibly be correct for so many organizations? So I think there's really a good merit to the asking that question. Have we really understood what's wrong with monoliths? Have we really understood why it is not working for us? So often we are eager to find a solution, but if only can pause to ask what did not work and how we could improve it, I think can be better. Here's one of the fears I actually have working with a lot of organizations looking at architecture is, are they really building a microservice, or are they building yet another service-oriented architecture and calling it microservice? So that's one of the things that I want to really question is, what problem are you really trying to solve before you propose a solution? And I think it's really a useful question to ask. Let's explain why what you built doesn't work before we find an alternative solution. So taking the spirit of that discussion, I think there's really good value in asking, are monoliths dead? I don't think monoliths are dead. We haven't really understood what actually killed it yet, if at all. And I think we should really spend more time, I think.
Yeah, and so lately I've read a text, and that text was about how the proposal was to use microservices, and I did an experiment. So instead of reading the word microservice, I put in the word module, and it turned out that the text still worked. So you can have interfaces between modules. You can have interface negotiations between modules. You can have modules that use different databases, and so on and so on. And it turned out that the whole text didn't really give a reason. It was meant to give a reason why you would use microservices, and actually it didn't. And that's why I think a statement that says that we should look at monoliths is actually very valuable. And there is another thing that I find interesting, because you were talking about distributed systems. So I would argue, as soon as you have a server that actually has a network plugged into it, it's a distributed system, because it talks to some clients, it talks to some database, there is some network equipment attached to it. So it's a different, the decision or the point that you do have a distributed system is, I think, different from the fact that it's a monolith or not. We do have distributed system because, unlike the home computer that I had in the 80s, the network is actually the computer, right? So that's the world we're living in.
Okay, thank you, everybody. Eoin, you're up next.
So interestingly, my suggestion continues the distributed systems theme. When I was preparing for this talk, I realized there were two technologies been around for a long time, which I've used repeatedly, successfully, to build systems. And it's lucky I picked the other one, because the first one was the relational database, which Nicki introduces to in the first step. The second one, though, I've been involved, in fact, in using these and also building them as system software. And I just think both of them are brilliant. Mine is message-oriented middleware, which is the kind of product everyone loves to hate, and yet nearly everyone's got embedded right in the middle of their systems, and they're absolutely relying on it. I always describe message when you introduce messaging, you're now into distributed systems for grown-ups, or maybe grown-up distributed systems, because everyone starts off with microservices, for example, or services with everything synchronous, and then they try and build something at scale and realize this has just got horrible qualities, and then they introduce asynchrony, they introduce messaging. Only they realize building their own messaging is going to be really tough, because it's actually a lot harder than it looks. So they introduce message-oriented middleware. And although they claim that they hate it, actually, they push lots and lots of complexity down into it. And what you know very quickly, they get magical improvements in their systems architecture. It's now more scalable. It's now more resilient. It's now more transparent as to what's flowing through it. They can use it for bulk data transfer. They can abuse it for all kinds of things it was never intended to work with. And yet, it's got such a simple model. It's just got really two concepts. It's got queues and it's got topics. You can explain them to almost any developer in 10 minutes. And yet, having a grasp of that, they can then use these magical message-oriented middleware products to completely revolutionize the qualities of the architecture of their systems. So I would argue that a lot of development teams have got a lot to thank message-oriented middleware for, as well as their relational databases. And it has stood the test of time. It's not as old as RPCs. It's not as old as relational databases. But I think TIBCO RV, which was the first kind of middleware I used, I think that was introduced in about 96, 97. And that was building on top of research prototypes. So I think it's been around, well over 20 years. And that today, it's quite hard to find a scalable system that doesn't have message-oriented middleware built into it, even if perhaps not too many people are using typical RV anymore.
I would say one of the things that really we should also be careful about is testability. And while the technology is really useful, it does increase the complexity from the point of view of ability to test it. And interacting with certain teams, I wouldn't be naming them here, obviously, but where they've gone overboard with the event-driven architecture, but did not take the care to really write enough automated tests and auditability. I've actually spent time with teams where the messaging layers really did not handle the errors properly, and there were production problems that led to years of issues, and they had to bring in a team of people to debug and find out what was going on. And this is not necessarily a rebuke against the technology, but more of how people get infatuated with it and end up using it, but don't spend enough time on the, maybe we should say, engineering practices that would make it sustainable in development as well.
I think you're quite right. And actually the big problem that I've seen big mistake teams make is they assume they run a tiny little broker in memory inside their IDE, and they test on that. And then they hope that when they move on to a 100-node massive enterprise broker, it will behave in exactly the same way. And what do you know? They don't. And they never quite learn the model. And they never, in particular, there are a whole lot of promises, but also constraints and unpromises that message-oriented middleware tends to turn up with. And people tend to kind of assume it is just magical. And unfortunately, it's not quite magical. There are a few trade-offs. Presumably, you've seen lots of problems like messages ending up being routed to impossible destinations and so never coming out the other end, that kind of problem. I agree, that sort of thing really needs good monitoring and lots of testing.
Hi, I'm Kevlin Henney. The software technology that stands the test of time that I'm going to suggest is the programming language. Specifically, the concept of a programming language is a text-based notation through which we program our computers and create our systems. And also the idea of specific programming languages in general, that programming languages tend not to die. So let me start with our second one first. Whenever anybody says a programming language is dead, if you look around, you'll still see that it's alive. Perhaps it's not as active as it used to be in its youth, but normally it's still around. There's normally somewhere running that code. There is normally somebody who has created a compiler or interpreter for that, or updated an old manual. The language is alive. It may not be very lively, it may not be on a growth curve, but it's still there. And perhaps a better word than death for a language is that languages become moribund. They reach almost the point of death, but not quite. And that's a really long tail. So whenever people pick a language, you normally find, yeah, it's not dead if they say it's dead. That's just clickbait. So I'm not suggesting that we immediately all go out and find languages like PL1 and Coral 66 and things like that and start skilling up in them. But there's a difference between not really very active and completely inactive, which is dead. So the first thing is that programming languages generally do not die. They just linger. Which leads us to this other observation, that for almost as long as programming languages have existed, and the earliest programming languages that were not just straight assembler were kind of conceived of in the 1940s. And we have things like plan calcul, dating to the late 40s as a notation that was not implemented for many years and never caught on, but was highly influential. We have languages like Algol and Fortran that came from the 1950s. Algol 60 was the proper first implementation that people started using, and that we still live in its shadow in most of the languages that we use in terms of things like scope. We have languages like Lisp that was designed in the 50s and was implemented in 1960. These still linger. They are still around. You know, go and watch The Martian as a film. The code that they show in that is Lisp. If you're using Emacs, you're using Lisp. If you're using Clojure, yeah, that's a Lisp language. In other words, these are still with us. If you go and look at the current jobs, all these languages are mostly old. you don't see a lot of people recruiting for things that are not languages. Oh, those things happen. They come up every now and then as a visual system, and there's normally a bit of popularity and excitement around them for a few years, and people say, oh, you know what, we don't need to code, or you can code in English. We've seen this before, and we've seen it arrive, and we've seen it leave from the very same platform. Of course, there are points of progress. There are systems where we don't use code primarily, but they have an interesting tendency. Perhaps the most widely used programming system that does not directly use code in the way that most people use it is Excel, except that it's also got VBA. And Excel has just recently acquired lambdas. So yeah, actually, it's a proper programming system based on a programming language, but it happens to have a convenient grid-based interaction model that most people are familiar with. So the point here is that I'm fully expecting that in another few decades, programming languages will still be there, and people will still be making the same complaints. Perhaps we could do this without programming languages. And they will discover that it turns out that the system of writing and the system of formalisms that humans have created are surprisingly effective, unreasonably so. And they're not going to go away. That's going to endure. So thank you very much. And I hope you have some thoughts about that.
Great. Well, we've had quite a combination of ideas here, from hardware and languages and language categories, architecture, system software. The variety has been quite fascinating, and I've enjoyed listening to all the recommendations. Unfortunately, we don't have time to do a closing vote, so you'll all have to decide for yourselves if you made a compelling enough case for your software technology that stood the test of time. I'd like to thank all of you for appearing on the panel, and thank you.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.